Hello chemistry fans, and welcome back to chemistry problem solving session here at the Academic Success Center for Chemistry 1032. I am your host, Dr. Russell Betts, and I'm going to guide you through this problem today. So let's take a look at it. Define the terms: isotonic, hypotonic, hypertonic solutions. All right, these are all kind of biological things, but we can explain it using a little bit of chemistry. Isotonic. An isotonic solution basically has the same osmotic pressure as a cell. So what happens in an isotonic solution, so it has the same osmotic pressure as a cell. So if you want, try my rudimentary drawing here. You have a cell and water is leaving, and water is entering at the same rate. So the cell will not increase in size, will not lose water or gain water, because the water will enter and leave at the same time at the same rate, because the osmotic pressure on both sides of the cell membrane is the same. Okay? This is a cell. All right. Hypotonic. Now, a hypotonic solution is a little bit different. What happens in this case is now the solute concentration on the outside of the cell is low, and on the inside of the cell, the solute concentration is high. That means the water will enter the cell. Okay? And that's because the solute concentration on the outside is less than that of the inside. So the osmotic pressure on the outside is pushing the water in. Hypotonic solution. Solute on outside of the cell is less, I should say, solute concentration is less than the inside of the cell. That means water will enter cell. And the cell will swell. Will swell up. So now we have our cell and we have a bunch of water, and the cell will get bigger. Okay? Until the cell may actually burst at this point. It's called hemolysis. The cell can actually, and all the cellular contents can leave the cell. In a hypertonic solution, the solute on the outside of the cell is greater than the inside of the cell. This means water will leave the cell. That means water will leave the cell. The cell will shrink. Shrink. Yeah, it'll shrink. It'll shrivel up. So if you want to, here's our cell. Here water is leaving, and the result of that will be a shriveled up cell in a process known as crenation. The cell will get smaller and probably not work quite so well because it's all shriveled up and stuff. So it all has to do with osmosis. It has to do with solute concentration. So when the solute concentration on both sides of the membrane are the same, water will just exchange. When the solute concentration on the inside of the cell is greater than the outside of the cell, water will enter the cell and attempt to dilute the cell, and eventually will swell it up and maybe even rupture the cell, which will not be good. Hypertonic means that the solute concentration on the outside of the cell is greater than the inside, and water will exit the cell, and the cell will shrivel up in a process known as crenation. All right, now with that, I'd like to say please read this part of the book. This is a hard thing to explain, especially in a short little video, and with my limited abilities with artwork. Please read it in your book. If you still don't understand it after reading it, talk to a tutor here at the Academic Success Center or come to my office hours. I'll be happy to explain it to you further. And with that, I'd like to wish you good luck and good chemistry.